faithfully sharing insights, exploring great books from around the world. Hi, this is Sally here to talk books. Today, I'll be breaking down the book, The Knot of Dreams. We all dream every night, yet we barely understand the secrets behind our dreams. Like, why can you, who's usually just ordinary, suddenly scale walls and fly in your dreams? Why doesn't it feel weird to you in the dream, even when things get super bizarre? Why do you sometimes realize you're dreaming while you're still in the dream? And why do you forget most of your dreams? Plus, what would happen to someone if they stopped dreaming altogether? These are the big questions that The Knot of Dreams dives into. The author, Alan Hobson, is a psychiatry professor at Harvard Medical School, and he's won the Sleep Research Society's Outstanding Scientist Award. He focuses on sleep and dreams, plus the history of neurology and psychiatry. He's written several books on the topic, making him a leading expert in dream research. Now, why is it called The Knot of Dreams? Well, it's different from old school dream interpretations like the Duke of Zhao's or Freud's. It's not about telling you what your dreams mean or how they connect to your life. It's all about the brain science behind how dreams happen. All right, I'm going to break down the book into three parts for you. First, what dreams are. Second, how dream experiences come about. And third, what functions do dreams serve? First up, let's dive into part one. What dreams really are. The clearest answer is that dreams are your brain's activities while you sleep. But to get a better grasp, we need to pin down how dreaming brain activity differs from when you're awake. Back in 1953, psychologists Eugene Azarinsky and Nathaniel Kleitman used EEG and EOG to study how humans sleep. Eye movement, well, that's just the motion of your eyes. They discovered that when people sleep, their brainwave activity is very different from when they're awake. But during one sleep stage, their brainwaves looked almost like they were awake. At the same time, their eyes kept darting back and forth, and they showed signs like faster heart rate, higher blood pressure, and relaxed muscles. Asarinsky and Kleitman called this phase rapid eye movement sleep, or REM sleep, and some folks refer to it as active sleep. So, the corresponding non-rapid eye movement sleep is quiet sleep. Further research found that if you wake someone up during active sleep, they usually report their dreaming, with dreams that are super vivid, fantastical, and bizarre. But in other sleep stages, the chance of dreaming is way lower. Even if they do dream, the dreams are kind of barren and lack any storyline. You might be wondering, what exactly are the differences in dreams across different sleep stages? Below, I'll use 3 dream reports as examples to break it down for you in detail. The first report goes like this. As soon as I fell asleep, I felt myself moving, like on a small boat gently rocked by ocean waves. This is a dream from the early sleep stage. These dreams are short and simple, usually only containing some internal sensations. Besides the dreamer themselves, no other characters appear, and emotional experiences are pretty sparse. The content is singular and hollow. Now, let's move to the second report. I was constantly thinking about an upcoming exam, wondering what it would cover. I slept really poorly because I kept waking up and then sinking back into worry about the exam. This type of dream usually pops up during quiet sleep. It's all about cognition, no sensory or hallucinatory stuff, but packed with strong emotions that match how you feel when awake. Quote, the third report is, I was resting on a steep mountaintop with a sheer cliff dropping down on the left and a climbing team walking on a small path on the right. Suddenly, somehow, I found myself riding a bicycle. I rode right through the middle of the climbing team. Clearly, I circled the entire mountaintop. But weirdly, while I was cycling around the mountaintop, my body never left the grassy area between the rocks and the cliff. This is a classic dream from the active sleep stage. It's vivid, lively, dramatic, complex, and bizarre with transitions between different scenes. People in such dreams have rich and varied hallucinatory experiences, like illusions of movement, auditory hallucinations, and sensations of weightlessness. So, why do dreams show these differences across different sleep stages? This is because in different sleep stages, the state and level of brain activation differ, which directly shapes the structure and content of dreams. Specifically, during sleep onset and the early sleep stages, people can replay a small part of their waking experiences. Therefore, dreams in these stages often have some link to waking experiences. For instance, the dream from the first report happened the night after the person took a boat trip. Also, during the initial sleep stage, brain activity is still suppressed, so dreams have fewer hallucinatory elements, shorter duration, and relatively limited scope of hallucinations. After falling asleep, we enter the quiet sleep stage where the brain's activation level is low and perception is dull or absent. Therefore, dreams at this stage lack hallucinatory components and consist only of a single emotional experience. After the quiet sleep stage comes the active sleep phase. In this phase, people suddenly experience physiological changes like increased heart rate, elevated blood pressure, and muscle relaxation. Meanwhile, the brain gets activated, but different areas are active compared to when awake. That's why dreams in this phase have the richest emotions and perceptions. Compared to being awake, emotional experiences in dreams are more primitive and intense, dominated by basic feelings like happiness, anger, sadness, and fear, while perceptions are mainly hallucinatory. All right, that covers part one. Dreams are brain activities during sleep, and differences in brain activation across sleep stages lead to variations in dream experiences. Now, if I asked you what dreaming actually feels like, you might describe it from various angles, like not realizing you're dreaming while in the dream, or encountering bizarre things without finding them strange, feeling like you've lived a lifetime in a dream, only to wake up and find just a few hours have passed. Having incredibly novel experiences in dreams that fade from memory shortly after waking, and so on. So, from a psychological perspective, how exactly do these experiences arise? That's what I'll cover in part two. When asleep, the brainstem automatically generates neural signals. Additionally, physiological changes during sleep and external stimuli received also produce neural signals. Different signals activate different areas of the cerebral cortex, creating various peculiar dream experiences. To deeply understand how these experiences are formed, we'll examine 6 aspects. First is self-awareness. During dreams, most brain regions active during wakefulness enter dormancy. At this point, a person's sense of self-awareness weakens, lacking introspection and unable to accurately assess their state. Hmm. Put simply, you just don't know what you're doing. Therefore, we often don't realize we're dreaming. Interestingly, we can enhance our self-awareness in dreams through some practice. To record dream experiences, the book's author repeatedly reminds himself before sleep to pay attention to certain details. These details could be deceased relatives or monsters. Godzilla-like creatures never appear when we're awake, but they often show up in dreams. After such self-suggestion, the author often realizes he's dreaming and can induce awakening at the right time, increasing dream recall. This type of dream where you know you're dreaming is called a lucid dream. And in a lucid dream, part of the brain is awakened in a conscious state and notices that it's dreaming. Another part of the brain remains in a dreaming state. In the Hollywood movie Inception, the protagonists often enter dreams in a lucid dream state to complete tasks. How do they remind themselves they're in a dream? By relying on things that can't happen in reality. For example, making a spinning top rotate forever without external force. Now, looking at the second aspect, perception in dreams. Endogenous perception, meaning hallucinations, activates spontaneously during sleep, making us perceive things that aren't real. For instance, rivers flowing upward, distorted houses, people walking in midair, and so on. However, channels for perceiving the external environment, like vision and smell, are mostly shut off when we sleep. Therefore, perceptions that rely on external cues, like sense of time and space, are lacking. This is also why it feels like you've experienced vast changes in a dream, but in reality, only a short time has passed. Actually, what we experience in dreams are different scenes, and how much time passes between them is filled in after waking up. For example, the first scene you dream is in the morning, and the second becomes evening. Then, after waking up, you might describe based on these two scenes that you experienced a full day in the dream. And the third aspect affecting dream experiences is thought and logic. Overall, when dreaming, the rigor of logical thinking decreases. So you don't consider whether certain phenomena or situations are reasonable. This can also explain why dreams are so bizarre, yet we often remain completely unaware. The fourth and fifth aspects are emotion and instinct. To put it together, when people are asleep, both emotion and instinct are heightened due to the activation of the brain's limbic system. Therefore, we often experience intense emotions in dreams and rely more on instinct to react. For example, many people have dreamed about exams, and these dreams are almost always unpleasant. Either there's not enough time for the exam, or they filled out the answer sheet wrong, or they were simply stopped outside and couldn't enter the exam hall. In such dreams, people often feel intense anxiety, helplessness, and even fear. But in dreams, they usually don't directly confront or solve problems. Instead, driven by emotions, they make a series of instinctive reactions, like crying hysterically, arguing with the exam proctor, or causing a scene in the exam hall. Finally, let's talk about the sixth aspect, memory. When it comes to dream memory, you might think dreams are too easy to forget. Indeed, our memory of most dreams is very brief. We can only recall the dream content for a short time after waking up. Why is that? To answer this question, we need to understand some basic knowledge about memory. Human memory is divided into three types based on duration: sensory memory, short term memory, and long term memory. Sensory memory is when stimuli that cause perception continue to act on the brain even after they are no longer present. This sounds a bit confusing. For example, you casually glance out the window while working, then continue working. Within 1 to 2 seconds, you can recall everything you saw. This is sensory memory. Sensory memory holds a vast amount of information, but only what catches your attention moves into short-term memory. Oh, yeah. If in that glance, someone outside catches your attention, they enter your short-term memory, and you can recall their appearance and outline within a minute. But more content, like other people, birds flying by outside, shapes of clouds in the sky, etc., since they didn't catch your attention, they are forgotten. If short-term memory is constantly reinforced and processed, it becomes long-term memory, which can be recalled over a long time, even for a lifetime. Back to the previous example, if that person outside the window happens to be your type, after seeing him, you're already planning how to go downstairs to chat him up, even mapping out your future life together. His image keeps popping into your head, so he enters your long-term memory. To understand the transformation between different memories more vividly, you can picture the brain as a warehouse with our memories as individual items. Only after an item is registered and stored can it be retrieved when needed. So here, sensory memory is like items on an assembly line. Only selected items enter the storage phase. Short-term memory is like things in a temporary storage room outside the warehouse. Only frequently used important ones are moved inside by the administrator. Long-term memory is the items stored inside the warehouse. When dreaming, we can pull items from the warehouse, meaning long-term memory can be effectively accessed. That's why people often revisit past scenes in dreams, seeing people from childhood or even earlier times. But since the warehouse administrator is asleep, moving temporary storage items to the warehouse stalls, meaning short term memory can't convert to long term memory, so dream memories only last a short while. If you don't record and process the dream right after waking up, recalling its content and details becomes tough. That concludes the second part. Let's quickly summarize this section. The brain's unique activation state creates different dream experiences for us. Changes in self awareness, perception, thought, emotion, instinct, and memory during dreams make them bizarre. Finally, we dive into part three. What functions do dreams serve? The book mainly covers two functions of dreams. The first function can be summed up as a survival function, meaning dreams are essential for keeping physical and mental activities running smoothly. French neuroscientist William Dement and his colleagues designed a dream deprivation experiment, waking subjects right after they entered active sleep. But subjects weren't woken when in other sleep stages. This is because research found that most dreams occur during the active sleep phase. Therefore, by preventing people from entering active sleep, you're largely depriving them of dreams. Results showed that after 10 days of active sleep deprivation, some subjects developed symptoms of mental instability, like constantly feeling unsettled, low mood, paranoid thinking, increased fantasies, and so on. Fortunately, after the experiment, letting subjects sleep properly and dream freely made their symptoms disappear. This shows dreams are essential for maintaining normal mental functioning. The second function of dreams is organization and restoration. During the day, our brains receive tons of information. At night, while dreaming, the brain processes this info, encoding and storing some, discarding and forgetting others. This lets the brain better handle new daily challenges. That's the organizational and restorative function. Many have experienced this after a bad day, maybe getting criticized by the boss or fighting with a partner, feeling emotional, ready to quit or break up tomorrow. But after sleeping, it feels like no big deal with a sense of clarity. That's actually the result of your brain working during sleep. I Dreaming not only calms emotions but also solidifies learning and practice effects. Psychologists conducted an experiment to see if preventing dreams reduces learning effectiveness. In the experiment, subjects were told to stare intently at a marker in the center of a screen. When something flashed elsewhere, they'd signal the researchers. With less than an hour of training, most subjects reacted very quickly. Next day, testing continued, but half were deprived of active sleep the previous night while others slept soundly. Results showed sleep-deprived subjects performed similarly to their first exposure, while well-rested subjects maintained practice effects with even improved performance. Our interpretation is nearing its end. We've covered what dreams are, their functions, and explained dream-related questions. Dreamscapes shift endlessly, but whether swimming, flying, escaping, fighting, or witnessing surreal landscapes, you experience a strong sense of self. Well, even though the actions or scenes in dreams aren't real at all, we're totally convinced that this is what I did. This is my experience. The self never vanishes in dreams. I dream, therefore I am. All right, that wraps up our interpretation of the knot of dreams for you. Keynotes are below the audio. See you tomorrow.